Welcome to the second in our Parkython book club. So this morning I'm saying this morning, that's because I'm in Melbourne, Australia. So this morning, this afternoon, this evening, wherever you are, we're doing the fourth chapter of this book, Norman Deutsch, The Brain's Way of Healing. And so can we just jump to the next slide, please? Okay, let me just get my screen rearranged. Okay, so this is the second in our, too many screens open, the second in our series. We're not medical doctors, we're not here to give medical advice with the Parkython group. And we're here because we want to engage with the neurotech community. This conversation is not sponsored by anyone. It's not supported by any neurotech companies that we may mention. It's just 5 individuals who form Parkython, and we're here to just have a conversation with the neurotech community. And I should mention, and I should just mention to my colleagues, so Rui, Kevin and John, who were here long before I was, and then Carly and I are the 2 new additions. And I should also say Carly's done lots of work for this presentation this morning. And so I should thank everyone else. I haven't really done nearly as much as they have. So thank you to Rui, Kev, John, and Carly for all the work on this. And during the chat, please feel free to, put your hand up on Zoom if you want to have a question to ask, or write something in the chat function on Zoom, or just whatever other mechanism you want to use. Please feel free to join in. It's supposed to be a dialogue, not us talking to you guys. So please feel free to join in the conversation. Okay. So like I said, it's chapter 4, Rewiring the Brain with Light. We're going to start talking about photobiomodulation applications in neurology today, but then switch very much to open discussion. Like I said, we want to get through us talking to you and really engage in the open discussion section as quickly as we can. Okay, next slide. And I'm whizzing through these. And John, please stop me if I'm missing any of the key points, by the way. Okay, photobiomodulation. Exactly what is it? We're not quite sure. There's one definition up here we've got. So we're going to use the definition that we're talking about red or near infrared light to stimulate, heal, regenerate, and protect tissue that's at risk of being injured, that's either been injured, is degenerating, or is at risk of dying. So okay, yep, next slide. Let's just pause for a second and try to talk a bit about what we're actually, what terms we're going to be using today. So photobiomodulation 101, this is labeled. It's really, we're talking about using, need to get across the concept of the electromagnetic spectrum. So everything from gamma rays to radio waves and everything in between makes up the electromagnetic spectrum. You think of radio waves when you're trying to pick up a radio signal on your car radio, or gamma rays or X-rays, which obviously much more intensity. And what we can see with our eye, or the bit in the middle there, the visible light. So when we go from the violet and the blue right through to the red, that's the visible light. That's the stuff your eye can pick up, you can detect. It's a very, very small bit of the electromagnetic spectrum. Like I say, you can see the picture below there, ultraviolet and infrared are probably terms you've heard as well. And the infrared bit is really the bit that we're talking about in terms of the near infrared, in terms of photobiomodulation. And it's just beyond what you can see at the red end of the spectrum. So if you think of a rainbow up in the sky, when you're looking up and you see a rainbow, there is actually other colors beyond what you can see. And if you just think of those things just beyond the red edge of the rainbow, that would be infrared, and your eye can't pick those up, but they're there. And also at the other end, past the violet, you've got the ultraviolet, and again, your eye can't pick up those wavelengths of light, but they are there. And so you're tuned to see the visible light. These other infrared and ultraviolet and other wavelengths exist. At the bottom, there's no test on this later, by the way, but at the bottom, we're trying to get across of what the concept is in terms of wavelength and frequency. And you can see as they get up the radio waves, the wavelength gets much bigger and the frequency gets lower. They're just interchangeable terms in this context that you could use, but it's the concept of the higher frequency tends to have more energy. So when you're talking about gamma rays and X-rays, they're higher energy. When you're talking about radio waves, much lower amounts of energy. And we're talking about, when we talk about the visible light spectrum, that's the white light. That's the light your eye can pick up. The blue light for manipulating the biological clock. That's part of the visible light. And then obviously in the infrared is what we're going to talk about for photobiomodulation. Okay, that's probably enough there, but please feel free, like I said, to ask questions if you want at any point. The other thing to think about also is the intensity. So it's not that the color, if you like, of the light is just the one factor. It's how bright it is. So if you think about switching on a light of a particular color, just because you raise the intensity, it might stay at the same color, but both factors are worth considering. So the intensity is often measured by lux, which is the lumen per square meter. There's different ways of describing the intensity. But you really talk about the flux density passing through a particular area, and that's one way of thinking about the intensity of the light. So you have lots of green light at a particular intensity, or lots of red light at a particular intensity. So the intensity and the wavelength are both worth thinking about. And try to give some examples there of different levels of lux. You think of low light or living room light right up to direct sunlight. Okay, so there are different levels of intensity, which is another consideration when we talk about neuromodulation, neurobiomodulation. Okay, has anyone got questions at this point? John, is there anything in the chat? Anyone want to ask any questions before we move on?
I don't see anything at this point. I think it's a great explanation, a nice overview.
Okay, thanks. Well, look, so I'll hand over to, is it Carly, I think is going to take on the next bit. Over to you, Carly.
This one, John, would you tell us about it?
Oh, John, sorry.
Nope.
So
yeah,
that
one.
Talk about photobiomodulation. We're talking mostly about animal models at this point, but there are certainly people testing this in humans now. It's absorption of the light through the mitochondria, which leads to the big part of this is really the ATP synthesis. That's the power part of it, but there's other components that also improve, I'd say, the health of the cell, and also decreasing apoptosis, meaning cell death, for survival. And again, I mean, my area is more related to Parkinson's, and specific to Parkinson's, it's mitochondria that is actually where we think a lot of the dysfunction is occurring. The mitochondria aren't able to efficiently produce the cell waste removal, and that's why this is of interest for Parkinson's, although, as you'll hear today, it's of interest to quite a number of neurological disorders. Wrong slide here. Okay. And this is just the areas.
All right. So photobiomodulation has originally historically been used to work on like sports wounds or like skin diseases, skin issues. But in recent years, they've been looking into it for neurological issues. So the symptoms that photobiomodulation has been seen to help for in terms of neurology patients is sleep. That's the big one. Depression, anxiety, fatigue, motor and cognitive deficit, tremor, and chronic pain. And in neurology, there are a few patient groups that are really like being looked into to benefit. The biggest one at this point, just because it's such a big market, is big population, is brain injury, concussion, but also being looked into a lot for Parkinson's disease, early onset Alzheimer's, stroke, ALS, seizure disorders. You know, some of these later ones are, some of them are degenerative. So this isn't going to claim to heal someone. However, it can make them a lot more comfortable and sleeping better and, you know, just live a much healthier life with the indication that they do have. Could we do the next slide? Okay. So next, we're going to talk about the applications of photobiomodulation in neurology today. What are the products? What are the treatments? So one of the easiest ways to deliver light to the brain is through the eye. So we're talking about the visual spectrum here, which is about 380 to 700 nanometers wavelength. Here are just a bunch of different lights and lamps that are largely like open to consumers to just buy. There are a few trials here for the Sunray, the Davia, and for the Celeste product. It's actually got a breakthrough designation for the FDA to treat Parkinson's. Though I know Bright Minds and Happy Light are just consumer products, which you can just put next to your desk or, on the table while you're getting going in the day or earlier in the day.
Yeah, and this is actually where it first came on my radar because a lot of the bright light therapy, not the photobiomodulation with the near infrared light, but using the blue light spectrum primarily, those are using off the shelf, over the counter kind of devices. And the authors in some of these studies, particularly Dr. Vidanovic, in the first one here, this is from a meta study that just came out, was using just stuff that you could literally buy on Amazon that was at the right spectrum. I listened to a lecture he did recently with the Davis Finney Foundation where he was talking, to a group of people, not physicians, and was saying literally you could get some of this stuff at the right temperature at the 5400K spectrum and be able to do this. And what he found in some of his initial studies were that people who were able to use this for short periods, 20, 30 minutes, a couple times a day, not too late, actually reduce their daytime sleepiness. If you look in here, there's some other studies that show changes in depression, show improved sleep function, and we know this is in other areas too, not just Parkinson's. But what I really like about this, and again, I just pulled this out of PubMed mainly because it was very recently published, is the quality of the evidence is very high. I like things that don't use proprietary equipment that requires a prescription and then has good high quality evidence and is non-invasive, non-pharmacological. That really hits a lot of numbers for me. So this is just a part that really caught my interest when I first was interested in it. And I think really was the person who put the photobiomodulation with the near infrared light. I think you put that on my radar with the folks down in Australia.
All right, and then switching a little bit to talk about near infrared light, that has to be delivered intranasally. This device here on the right, the Vi light 810, is put in your nose, and it illuminates the near infrared light. It's also being looked. There's a study with the Vi light and the Medex console system together to look at transcranial, putting it on your skull, in addition to intranasally. On the more left, we have this red light hat, which is kind of a DIY, do-it-yourself bucket that you put with an LED or near infrared light, and that's found to help with Parkinson's symptoms. Then going all the way to the left, of course, is the BioFlex laser and LED system, which was actually talked about in The Brain's Way of Healing. So originally they were putting this device here that's on the man's neck, they were putting that directly on the skull. And I talked a few days ago with the director of clinical research at BioFlex. He's an MD, and he told me that they actually don't put this LED on the skull anymore because they found largely that it works best not having to penetrate like the skull. Would you go to the next slide, actually? I'll go a little bit more in depth about BioFlex. So on the left here, we have an example of LED, which they're putting on the cervical spine part of your neck. And this is found to not target neurons, but to help the astrocytes, white blood cells, and glial cells, which are like adjacent to neurons in the central nervous system. So just helping those start to function correctly. And then they're also doing this sort of like near infrared laser. If you see this pen device, they will put that on the skull and put it like at a certain spot on your skull for about 7 seconds. It really helps if you don't have a lot of hair. So some patients even will buzz their whole head just to get this treatment and get it working, because it's hard to penetrate through the skull. They'll do 7 seconds per spot, move to the next spot, next spot, next spot, next spot, for about 10 minutes in total for the treatment. And then patients will come and do the treatment every other week, for however long it takes them to start to feel better. The clinical research director told me that the 4 main symptoms that he sees patients be alleviated from are their mood, sleep, and somatic and cognition areas. The patients that they've treated have multiple sclerosis, Parkinson's, early Alzheimer's, stroke, seizure disorder, multisystem atrophy, ALS. The biggest one, he said, is concussion. In Canada, concussion's a really big thing with the hockey that they just love up there. But this was pretty interesting, just to learn that they're not using it in the same way that they originally were, especially when this book was written in 2013.
And is it approved for concussion, or is it just used in general clinic for? I mean, a lot of times you'll get a device that we can use. You could use like iontophoresis or something like that, and you can use it for whatever is indicated by the clinician. Is that?
Yeah. Yep. It's just a very general approval, and it's like a lot of these clinics that are using the device, administering it, they're starting to compile like best practices for these neurology patients. And what they found is they want to clean up the cervical spinal, like cerebral spinal fluid on your neck with the LED light, and then they do the laser pen. Brain or BioFlex is actually conducting a few studies right now with concussion, just to get these case report kind of anecdotal best practices, like in a real thorough evidence database, essentially.
Sure. Okay. Ready for the next slide?
Mm-hmm. And this one's pretty interesting. They're starting to look, or some doctors, some researchers in France are looking into delivering near infrared light directly in the brain with an implant. There's a pilot of about 7 patients that have Parkinson's disease who are in this 4-year study to see how delivering light directly to the atrophying part of the brain can work.
What's so interesting about that, because we had a discussion, we read the book, obviously, and we go through this, and Mark, who has probably a very strong science background, like, well, how's it getting through here? And I think it's a good conversation to have about where is the light going through to. And there, with Parkinson's, there's a kind of a gut brain connection. So there's a theory maybe you could do it in the abdomen, which wouldn't have the brain to go through. And instead, here in Grenoble, one of the people in this study is Benabid, which is a huge name for deep brain stimulation. They're actually bypassing that, and they're putting it directly into the brain, and the illumination is on the pars compacta of the substantia nigra. That's at SNPC. That's exactly where the dopamine neurons are disappearing in Parkinson's. So they're really taking it to the source, and I think that's very interesting. And this is a very well-known lab, one of probably the most well-known labs, just because of their early work with deep brain stimulation. It kind of reminds me a couple years ago when they were using BDNF, brain-derived neurotrophic factor. This was a study published or funded by the Cure Parkinson's Trust and other entities, and they actually put ports where they had the ability to take that substance, which is associated with neuroplasticity, and people who exercise more have more brain-derived neurotrophic factor, and they're actually pushing it deep into the brain to provide the benefits. And that study had some mechanical issues, but they were showing some positive signaling, as we say. So this is really fascinating. When she showed us this the other day, when Carly brought this up, I was like, holy cow, this is different. Not that this is not valid, we're not saying that, but they decided to go right to the source by putting this into people's brains, into the part where the water is, into the vesicles, and I'm sorry, into ventricles. I'm sorry, and I think that's pretty cool. I would like to be one of those 7 people if I had to have this option. This is a pretty cool study.
And can I, just as we about to enter the open discussion, I should have noted at the start, but before anyone else joins in to talk, that we are recording this this discussion, and for possible posting on YouTube or on another platform later. So if just be aware of that if you want to join in the conversation. But yeah, and picking up on what John said, that slide I've got up on screen now, but but yes, so like that, but instead of putting electrodes into your brain, they're putting some sort of mechanism to let the light be inserted into the brain as well. So you're firing those near-infrared photons instead of electrons into the similar part of the brain. But that looks pretty interesting, I must admit.
Yes.
Did you wash your breakfast dishes?
It's very soft tissue, so it probably manages itself quite well. I mean, it's much easier to get into that than it would be even through the skin, I'm imagining. Again, a little bit above all of our pay grade, but when I saw the people involved in this study and where it was, and the fact they were doing it in the brain, that really had my attention, for sure. And as far as hopefully people got the notification when they logged in that it being recorded, we like to be able to.
So Zoom should tell you it's been recorded, but I think it's good to let them know on now. But yeah, was that our last slide in terms of introduction slides?
I think so. Yeah.
So it's over open discussion, and I must admit, I'd love to hear from not just my Parkython colleagues, but from others, questions, comments,
Sure.
thoughts on these matters. What did you think of the book, chapter 4?
Susan, I think if you can unmute, we can hear you. Oh. Yeah. First of all, maybe among the people that are here, I mean, do we have people who've read this book either purposely for this class? I'm having a little bit of unstable internet. That's why I have my camera off. So Susan, did you have something you want to add? Or no? Okay, then yeah, we got it. Okay. My point is that the book itself, it's an interesting topic, but I think that generally speaking, we've been looking for the data on it. I'm wondering if anyone's ever tried any of this stuff, because I think the data is going to come from the trials, not so much. We're not going to understand why it's working before we understand whether it's working, I have a feeling.
Yeah, I mean, I guess one of the things I find, John, is that it's not even just understanding how it's working. I mean, things like deep brain stimulation have been around for years. I still don't think we understand how that works, but we know it works in certain situations, and I think really this is what we're hoping to do with some of this neurobiomodulation, that we try to find things that work even if we don't quite understand why. But yeah, it's still early days, obviously, for some of it.
Especially because except for the study we just mentioned in Grenoble, it's pretty non-invasive. You're putting a light in there, you're using something externally, and fairly safe compared to, I mean, not that deep brain stimulation is not safe, but it is brain surgery. And again, the pilot study you're talking about, that's brain surgery, so that's pretty invasive, but for the most part, I kind of like DIY. I like stuff that you can do pretty much on your own, and also maybe quantify your own results, and then hopefully the publications are forthcoming.
Yeah.
One thing I was wondering about, just because it seems like sometimes people with deep brain stimulators are excluded from like certain studies or treatments. I asked the director of clinical research at BioFlex, can people with deep brain stimulators use this treatment? And he's like, yes, and they do, because they're just targeting really different systems that aren't, they're not conflicting.
Yeah.
The BioFlex laser is just like general brain health.
Yeah, that's
You
what
know,
what got up to me when I saw the study. Well, not exactly a study, a DIY that, like John was saying, in Tasmania, the helmet, that was something that popped up because it was non-invasive. I'm all over. No, I mean, anything that's non-invasive is always great because you cannot be fixed to it. You can test it in several times, and won't harm you and be permanent like a tattoo or something like that. Yeah, but the one in it's a shame that the DIY is still so far from the final clinical trials. I mean, it's already used for other situations. I mean, the guy that did the test DIY in Australia, in Tasmania, he just was using the light for treatment of the leg or knee injury, and he said he thought himself, maybe if this works for this, maybe it works for my brain. Maybe it makes my brain work better. And that's how he started. That I mean, he just asked for an engineer, a friend of his, can you please mount something similar like this for my head? And he just, it's not a good approach. Of course, it's just it could have been gone really wrong. But he had the test trials for the knees and something that was already used for the body. That was already something that was not so harmful. Yeah, but it was something that made people be aware of it and start looking at it in different approaches, because there were good results on it.
John, I can see you put your hand up.
Well, and I just want to say that, I mean, I think the risk of it going wrong, I mean, this is kind of what I like about it. You mentioned, Carly, it was been used for orthopedic injury, for skin stuff, and then Rui, it's like it's already got FDA approval. It's already been used in other environments. Again, it kind of feels like when we're talking about repositioning medications, we're taking things that are already approved for other diseases, and they seem to have applications in Parkinson's or other areas. Actually, there's a new ALS drug that was approved by the FDA, and I noticed that it was including a medication that someone was studying for Parkinson's for a particular DJ1 abnormality. And so I think, again, going back to the tech side of this, LED particularly, not any particular, it's not a focused laser, so you don't really have to worry about the eyes the way that some of the earlier versions of the lasers did. And so I think it's even more so. And then again, going back to what Dr. Vidanovic was publishing, off the shelf, we use a lot of lights. We do some classes where we have a studio, and so we have all these big bright soft boxes, and it's exactly that. It's like I feel like, hey, I'm teaching a class and I'm getting a dose of the right temperature of the light for an hour. You know what I mean? It's like fairly safe. They've done all that, and that's what I like about it. Besides that, you can do it yourself. And I'll go back to one other thing you said, Carly. Something that you said about not being able to do research for people who've had deep brain stimulation. It's a very frustrating thing. There's a couple areas where we don't let people into certain studies, and DBS is one. I'm on the scientific advisory board for the Davis Finney Foundation. We had this conversation maybe 3-4 years ago when we were in Indianapolis, and we're like, hey, all these studies that someone who's gone through this treatment can't be a part of, and that's a growing population that needs to be served. This group of people that are going to be more and more each year, especially as that surgery becomes better and better. But also, it reduces the science, because now you're saying it's really for one very specific person, only person who hasn't started medications, and only hasn't, like, that's not helpful. So I think that's valuable.
Yeah. No, I mean, as a traumatic brain injury survivor, I've been like slashed out of a lot of different treatments because I have a brain injury. And it's like, okay, but like, maybe I'm the one that needs it the most. Hello. And like, I tried to get Kevin to get involved in that psychedelic study for Parkinson's at UCSF, and they wouldn't let you in, right? Because you have a DBS.
I don't think he has DBS, but they wouldn't
I
let him.
haven't
In
been DBS yet, but they disqualified me for some reason. They couldn't
Oh,
even
is it something
explain why.
else?
I went through a whole interview process, and maybe I seemed too excited about it or something. But
They're like, I'm going to do recreational psychedelics on the
Right.
Yeah, okay.
I'm pretending to have
Rui-
Parkinson's.
Rui's
So I
got-
stayed
Rui-
in the city.
Yeah, Rui's next. Here we go.
Rui's got his hand up. Yeah, Rui.
Yeah, I was actually on the previous part where I was trying to remember that there was another factor that got me interested in the photobiomodulation, and now I forgot it. Let me let me recap what I was thinking. Going back.
Heard it helps with memory too, man.
Yeah, it's I need it for my brain clearly to make it fresh. Yeah, it was. Oh, you guys continue. I'll remember in a couple of seconds.
Yeah, we'll come
When
to
it
the
comes,
end.
put the hand right back up. Yeah.
Yeah.
But any other voices want to join in? Anyone else got a comment to make? Or?
I was gonna say there's the whole circadian rhythm aspect of this too that's kind of interesting, because just even with my own self, I haven't experimented too much with the photobiomodulation yet, but I do a lot of I wake up in the morning when the sun comes up, and before I go to bed, I start turning the lights to warm yellow lights and avoid the blue screens and the computers, and it's really helped improve my sleep quite a bit. So. But anyway, Rui, I think your hand went up again.
Yeah, I just remember that I was mentioning because there was another factor that dropped in photobiomodulation last 2 or 3 years. It was a pandemic, because when you're inside, you usually not getting the whole spectrum. So the photobiomodulation spectrum is also needed, especially because people didn't go outside to exercise and stuff like that. So anything that you could do that is not pharmacological, it's always great. So it was something that people start noticing, all the things about lights, because everybody was inside. So all the spectrum was cut out. So people just kind of start investing in solutions to bring the spectrum back into the house. So the photobiomodulation was just one part of the spectrum that could help on that. Improving the health inside the house, inside the walls, let's say.
Got a comment there from Roy. It's yep. Hey,
Right.
Hey, how are you?
All right.
Hi. Listen, this is a little bit off topic, but let me just mention it. I just signed up for Picnic Health, and what they are a research group that for certain diseases, Parkinson's, Huntington's, which I have, and they sign you up, and then they look at your medical records, and then they make the medical record available to researchers. And I'm signing up my father, who had Huntington's disease, my son probably, but Parkinson's is one of the things that is mentioned. So I just gave a link to, I put a link to it. Right. So it just is something you can check out, and I signed up for it already, so I'm kind of interested in it.
this looks great. Is it? Can I ask? Why is it? Is this just for the US or
It's
which country?
US only at this point.
Yeah, okay.
No, it is US only at this point.
Yeah. Oh, this is
Wow.
great to see.
It's on my to-do list right now.
Yeah. Now this is great. I must say I do find that in different countries there's quite different rules around access to health records, and I
Yes.
find in Australia I find it's the opposite. When I had my deep brain stimulation surgery, I asked when I was in hospital to see the medical record, because I thought they'd made a mistake in one of my what the nurse had written in my record for medication. I suppose the gait was not the same as what I'd heard the doctor tell her. And I asked to see my medical record and was told I wasn't entitled to see it. It was
Yes.
I'd have to put in some sort of freedom of information request or to get the see. It was quite ridiculous actually. But so it does vary from country to country. But this is very interesting. So sorry, John, I can see your hands up.
By the way, in terms of your thing, there's a guy named E-Patient Dave DeBronca, who is about liberating your medical records. You might want to follow him. He's a neat guy.
I love the E-Patient Dave. He's one of the reasons I'm here today. I saw him at a Quantified Self event many years ago when he told his story about how he had stage 4 cancer, and the doctors told him to pack his bags and say goodbye and everybody, and he fought back and started getting on the internet and talking to everybody and engaging in discussions like this. And
This guy?
Yes,
yes, that's
the guy.
he actually spoke at World Parkinson Congress too, in Montreal, back in 2013, right after I got diagnosed, and it was a great keynote speech. He talked about, when the doctors said they can't give you a false sense of hope, but he said, why not give us a false sense of no hope at least, or something that we could turn around and say, hey, there's solutions out there. We just have to work as a community to find them and kind of measure our results as we go. So.
Oh, look, I think this is great. Thank you for that. And John, you put your hand up.
Yeah, first of all, Dave is awesome. I saw him speak. I think Sarah Rigger put him on my radar, but I was at Montreal, so I must have seen him there too, because that was before I saw him at that. Stanford used to have this thing called Medicine X. I don't know if they're still doing it, but great participatory medicine. Kevin, you're the one who put this on my radar. I saw a bunch of Facebook ads, and I immediately thought, many people with Parkinson's, I think, would like to get this. I think it can go the last 7 years, because as a medical provider, you have to keep at least 7 years of records on hand, and then usually a lot of larger institutions put them into the shredder as soon as they can. But that's neither here nor there. But I thought immediately, I said, I think there's a lot of people, not just Quantified Self folks, that would really like to be able to look back in their records and see it in a way that's comprehensible and maybe start to see the patterns. I thought it was really powerful. So I think their value proposition is very interesting. It kind of reminds me of the early 23andMe that came out, where they were trying to specifically get a cohort of people with Parkinson's. And I think it's a win-win. Obviously, I'm sure their business model is we're going to have tons of medical records, which in the United States can be very difficult to aggregate, very expensive. We were trying to do a study maybe a decade ago, and to get them at that point, it was owned by Thomson Reuters, and to get some of these data sets was going to be tens of thousands of dollars by the time it was said and done. And then for a lot of it in the United States, you're talking about Medicare records, which starts at 62, and that's for people early on. So I think this is a really cool idea. And again, I think you have to trust in the system that they're going to have your records and your data. But I have a feeling it's all. If you look deeper into their website, they will share it with other researchers as long as you promise not to de-identify and do other things. So I think it's as safe as anything else can be. Let's put it that way, right? It's pretty cool.
Yes.
That's it. That's all my bloviating. But I think it's a cool idea, and I think I could see immediately when Kevin says, I think a lot of people with Parkinson's are going to be in other injuries and other disorders. Huntington specifically, Roy. You had genetic counseling. I imagine. Did you find out Huntington's has a gene that we can see, right? We can see
exactly.
It. Yeah. Not the case for Parkinson's, but not the same.
I have 40 CAG repeats in a particular gene, and that's how I found out.
Yeah.
That's what I found out.
That's still on the lower end of the spectrum. Is that correct? They can have much higher, or where does it sit?
It can be higher, but it's where you're symptomatic at that point.
Did you know? Other family members? Did you have it before, and you knew it was in the family, or was it a situation where?
Well, my father was moving he moved a little bit weird, and he wouldn't tell us what it was about.
Yeah.
And I told him, I'm sure you'd tell us. I know you love us. I'm sure you'd tell us if it's something to be passed on. And he said, I'll get back to you. And then a couple of weeks later, during the financial crash, he says, the family lost money with Madoff, and I have Huntington's disease. And that's how I heard about it. So,
That's bad.
and then he was being seen by a Parkinson's neurologist at NYU, but I knew that Columbia had a school that had a specialty in Huntington's disease. So I switched hospitals, and he got better treatment, and he had mood. He was treated for his mood as well as just movement.
Sure.
Because he's a very angry person, and the Huntington's disease may have been part of it. I mean, he had a gun, and at one point he was angry at someone in the office. He ran after him. He pulled a gun on my mother at one point. My
Very
mother
frightening.
took him down.
There was a This American Life many years ago where they talked about the story of this physician who was somebody in a kind of a small country area, and then his personality was changing, and it turns out it was undiagnosed Huntington's, and the anger and that kind of stuff was a manifestation of that. It's scary.
Yeah.
You hear about that with chronic traumatic encephalopathy as well.
It can be for a lot. I mean, anytime that you have changes in the frontal lobe, you're going to lose your ability to manage that stuff. So that's terrifying. But good find, good interesting thing. That's a nice little San Francisco startup, probably right there by Rune Labs, right? In the same area.
That's right.
They have all the coolest stuff, and worth checking out. And again, I think their value proposition is very interesting, especially if you're doing this and you're doing it over the course of years. You'll have 15 or 20 years of this long-term data. Go ahead, Carly. I don't want to talk too much here.
Oh, I was just going to say that it reminds me of this company that's really making headways in the psychedelic field. It's called Quantified Citizen. I'm going to share my screen. And so this is like basically like an open source app where anyone can participate in a study that just happens to be doing some kind of like psychedelic. I mean, they originally, I think, started with like nutrition for like people trying to do sports, bodybuilding, weightlifting kind of things. And then they were like, oh, wow, well, we could actually gather a lot of data, people doing microdosing of psilocybin or LSD or, things like this. And if we get enough data, this can fund, the real trials for more niche things that I'm trying to find the name of a study that I've heard about, which has got like some 10,000 people microdosing on psilocybin mushrooms, which is really cool.
I could imagine a study where you couldn't get it done because there's nutrition studies are very difficult to do properly, and a lot of times they're retrospective. But I can see if something like this, the Quantified Citizen.
I know what it's called, microdose.me. This one, this is the study I'm thinking of. Their largest mobile microdosing study for psychedelic substances. So this is being run by a guy named Paul Stamets, who is a huge mycologist, which is really cool. But I really like that it's taking the barrier down from studying this stuff. And they tell you exactly what dose to do, what quantity, and then they have a really nice app that you just report everything.
So could you do something like that with one of these light things? Could you do, getting kind of more quantified self, Kevin, who I know this is really your world. Could you make something like this and try out? It doesn't have to be a light thing. It could be something else. It could be a meditation app. It could be something like that. It's pretty cool.
Neat.
I like it.
Yeah, it's interesting though with the photobiomodulation. It's not getting. I don't come across it. It was interesting to read this chapter that be drawing attention to this chapter 4 of the book and have this conversation. But it's sort of, I don't know people who are trying things or doing, working in this area. I don't know, maybe it's in Australia, we don't have as much activity in this, but it's not something I hear about. You know what I mean? Like you hear about people trying medications, and you get pump infusions and DBS and various things. And obviously, people talk about health being your diet and your stuff, your sleep. But I don't really hear about photobiomodulation being something apart from when you read the odd research paper type thing. Is it the same in North America? I mean, is this something that's a lot off, or is it just something that really is very much a niche?
You have to join the right book clubs, Mark.
Yeah.
No, I think
Does anyone know someone who's actually been trying these things? Like, do we know people who
Well,
are
I
trying?
actually saw an interview in another blog well, I think you guys know the non-cellular bullet. They have an interview with a lady that actually was part of the
Two of them.
Yeah, two of them. The follow-up. We can share it then afterwards for anyone on follow-up on our blog. They did two videos with the persons that were in Australia, in Tasmania, that test, and there was I was also a clinical trial. I'm not sure if it was only phototherapy or photomodulation, but it was also in Australia. I'll look it up for you. I didn't find it yet because it was a long time ago, like before the pandemics. But I think they started. I know they started one in Australia. We can look it up later. And but it's not. I think it's not something that you hear about a lot because it's used in other pathologies, but not so much in Parkinson's because it's not a highlight, and it's a more recent in Parkinson's. But that's my view.
I wanted to make one of these. I'm a clinician, but I thought it'd be kind of cool to put one of these together, and it was a little more engineering than I thought I could manage. But I thought it was kind of cool. I wonder if that's a bit of a barrier. Again, they're publishing in journals that I think are still they're. It's not movement disorders, but it's a good enough journal to have my attention. It's not one of these junk ones that come in my spam folder asking me to be a keynote speaker at one of their conferences or something like that, right? I get about 1,400 of those every week, but so I think that's real. It's just the DIY is a hard part of it. Maybe understanding it. Where we're getting back to what you're saying, Mark, right? If we don't understand it, and this is the conversation we had before when we were preparing. It's okay that we don't understand it. Give me enough people who are showing benefits and quantify those benefits in a way like with a unified Parkinson disease rating scale or something else that you could be using.
Yeah.
That's what the. What are you saying, Roy?
Yeah, I was saying part of the reason we're doing this talk is because of that. I mean, I tried to share this information here in Portugal and around friends and around Parkinson communities to see to feedback from other countries, from the other ambassadors, and it's something that you're right, Mark. It's not something that is very common around the world. I mean, it's almost starting to in the Parkinson's area. Okay, so the clinical are. So the more we spread and more we talk about it, the more people get interested and work on it faster. And if it works, I mean, it's not non-invasive. It's a magic word, and it works in all. It already works for several pathologies. I mean, why not for Parkinson's too? I know John doesn't like to be too much technologies that works everywhere, but if it works, it would be great.
Well, I want to be gentle with that because it can be a bit of a red flag. If anybody hasn't checked out Benzie Kluger's work, he's got a new book that he's working on. It's going to be about medical BS. He says the word, but I won't here because we're going to go on YouTube. And I think one of the red flags is something that treats everything, but at the same time, kind of coming back to the origin story of within the book, it's like the guy was using it because they had an issue with, I thought it was arthritis. Yeah. Yeah, there we go. Cool. Yeah. Ben's a movement disorder specialist at the University of Colorado for a number of years. Was actually the helm of that program, and then formed a neuropalliative program that was one of the third one in a country, or maybe even in the Northern America, and now works at the University of Rochester, bringing that to a much larger community. And this has always been an area of his passion. He's such a great presenter. He's so down to earth, and he's super intelligent. And so I highly recommend, if you get a chance, to check him out. But again, he'll talk about, like, he went through that. What is that thing that's sold on? Every time I go visit my dad, and he has commercials on during like Jeopardy, and he's being targeted with. Name me a supplement that you can get at like Walgreens that's supposed to help your brain. Supposed to be like for your memory.
Oh, yeah, but I need some.
Yeah, well, but he goes through. I'll find it here in a second here while you got it, because I don't need to talk the whole time. But he goes through why is that terrible? You know, like, this is not really that valuable, right? But at the same time, going back to the origin story, being used for an orthopedic problem, or maybe it was arthritis, and started noticing the other benefits. That's the way a lot of this stuff happens, and it's okay. I'm not. Yeah. I don't want to throw the baby out with the bathwater. I do want more studies, and I want the studies to be large enough N that you can really power them properly. But I could say the same thing about a lot of rehab research. There's a lot of small, open, not double-blinded. So, I mean, it's not like I'm Cochrane, and I'm like, you need to have 3,000 people, and it needs to be like I'm not saying that, right?
Roy, yeah, go ahead.
I have just a question. Remember we were earlier talking about mitochondria, and that's being affected, and a mechanism you have to deal with. I have heard of autophagy as something that cleans out helps the mitochondria clean out. And there's a drug that's available I'm taking a drug that supports autophagy, and it could conceivably be used for Parkinson as well. There's photobiomodulation is one that crosses a blood-brain barrier. Now, I mentioned that to Sarah Riger, and she said, you're not allowed to take a drug off-label. But since I have a little bit of high blood pressure, my internist prescribed it for me.
Oh.
And verapamil was another one like that.
It's a calcium channel blocker?
Both calcium channel blockers, yeah.
Oh. Yeah, I was curious because sometimes I do intermittent fasting, and when I do, I feel my energy level and my brain fog goes away. My energy level goes up, my brain fog disappears, and it's just so hard to run the house here with the kids and cooking food and eating all the time.
Yes, I understand. But anyway, those drugs, I could, I've been taking them for as long as I've had Huntington's disease, and it's helpful. And I heard about it actually in the Stanford Hope site. There's a site about Huntington's disease run by Stanford students. And they mentioned verapamil there. But since I have a little bit of high blood pressure, I'm able to take it. And then photobiomodulation crosses a blood-brain barrier, which I thought was better.
Yeah.
There's been some interest in calcium channel blockers. I'm trying to think of the name of it. It is the kind of thing where I remember this study from about 8-9 years ago, and it'll pop up. And what's interesting about that, again, if it's already being FDA approved for another condition, and especially for blood pressure, like the nilotinib, that's a Cigna study out of Georgetown, it actually ended up not showing the results they wanted. But that's also a fairly heavy-duty chemotherapy drug that you're taking at a much lower dose. That's not as like, oh, that's okay. Whereas, again, a calcium channel blocker, especially if you have one of the indicated conditions, that's very interesting. I like that. I think this is another area where I think data science becomes very powerful, because we're able to do this much larger review of medications. Like older tricyclic antidepressants seem to have some benefits and can provide some relief. And those are not ones that people would normally take, but for Parkinson's, they're finding that. And it's like exactly what you're talking about, Roy.
Yeah.
So just to go back to the mitochondria, sorry, I lost our target here. What they don't know if this is coming, it's like a cart or the horse situation. Is it a situation where the mitochondria lose some of their power and therefore aren't powering the cell properly, and therefore the garbage is not going out? Or is it a situation where the garbage is getting clogged up for some other reason, and therefore it fills up the cell with too much garbage, and then the mitochondria start not working? There are genetic models, like genetically modified organisms that we could study where they actually target the mitochondria, and then there are certain genetic forms of Parkinson's that have mitochondrial dysfunction as a kind of a key feature, and that lack of mitochondrial function, that lack of energy production, makes these people at a risk for a certain kind of Parkinson's. And so it's all kind of in the family, chicken or the egg. It's hard to say, but you're right in the right area for that. And then taking it to blood-brain barrier. Go ahead. Yep.
There's a researcher, Steve Finkbeiner at UCSF, and he gave a talk about autophagy, and he's actually talking about which I could actually find for you guys, and he has a mechanism that he's studying, and I happen to be taking a drug for autophagy. What about drugs? Really, but I heard about him. Mentioned back 11 years.
Sorry, Roy, I don't know if it's just me. Your audio is breaking up, mate. We couldn't quite hear that last sentence or two. Do you want to try again?
Yeah. Okay. Okay.
Sorry, Roy, it's dropping in and out.
Oh.
The video is fine, by the way. It's just the audio, so I don't think it's a Wi-Fi. Maybe just the microphone or whatever.
I'm gonna switch.
Problems.
Yeah, take it. No hurry. Yeah.
Is that better?
Yeah, go ahead. Yeah.
No.
Bring the mic element up towards your mouth a little bit.
Yeah.
Hang on.
We might want to do the wrap up pretty soon. We're at time.
Okay, yeah.
Yeah, we're at time, but just give Roy a second. Yeah, go ahead, Roy. Roy, we can't hear you at all.
Cannot hear you.
Select the microphone on the side there. Make sure you have the right microphone being on now.
Yeah, you have to switch in the microphone, the switch in the Zoom.
Right where it says mute.
Roy, we can't.
Not yet. You have in the Zoom.
We can't hear you, Roy.
In the Zoom, there's an option that you have the microphone. You probably have there the headphones.
Hello, is that
Okay,
better?
that's great.
Oh,
there
we
you
got
go.
you. We got you.
Great.
I'm
Go
sorry,
ahead.
so sorry. But Steve Finkbeiner was looking for families with Huntington's disease where there was 2 generations that had it. And in my family, there are 3 generations, my father, me, and my son. So what he did with the patients is he met them, did a neurological study, but also took their DNA, so we had that, and took skin cells and made them into spiny neurons, and he tested drugs on them. So that was really some interesting research. But I don't know if anything came of it. But actually, they've published it in different things. But
Thank you for that. Look, I am encouraged given as a prompt. I am conscious of the time. We've just gone the hour mark, and we could keep chatting, but I'm really enjoying the conversation. But we formally are at time.
I think we're taking a little holiday break, and then the next thing we're going to be doing in December is going to be related to deep brain stimulation. I know this is an area Mark will expand on, so to be continued. But this conversation, even when we got a little bit of far afield, really very interesting. I loved it.
Yeah, definitely.
Yeah, no, that was great. Thanks, guys. Thanks for that. Maybe my Parkython colleagues just stay online a bit longer, but we'll wrap up the formal book club now. So thank you very much,
All right.
everyone.
Good. Thanks all.
Bye.
Good night.
Take care. Good to see you.